Hi there, welcome to Geometry A. This is Mrs. Brunk. Today's lesson, section 7.2, or module 7.2, is going to be focusing on a couple of kinds of triangles that we sort of use these terms quite often, and probably officially, at least in this course, defined what the terms isosceles and equilateral triangles mean. It is something that we learn kind of early on when we study shapes. Triangles are pretty basic shapes, so we study them a lot. It's just kind of like with quadrilaterals. Like, we haven't specifically introduced terms like parallelogram and trapezoid, but they are things that you've learned about as you studied shapes in your educational background. So today we're going to make it official. What does the word isosceles mean? And therein, what is an isosceles triangle? And what about equilateral? What does that mean? So our learning goal will be to be able to define what an isosceles and equilateral triangle is and to use its properties. So an isosceles triangle is a triangle with at least two congruent sides. So that phrase "at least" is really important, at least. So if it has two sides that are equal, it's isosceles. If it has three sides that are equal, which means all three sides, since a triangle only has three sides, it also means it's isosceles. It's just a special kind of isosceles triangle that we have a special name for, and that's equilateral. So, but in general, as long as a triangle has at least two sides that are congruent, then it's isosceles. Anything we learn about isosceles triangles then would be true for triangles that have two or more sides equal. Now, remember when we studied right triangles, they had some special names for parts, like hypotenuse and things like that. Well, when we study isosceles triangles, we also have some special names. And some of the names we use are the same ones we use for right triangles, even though these are not right triangles, and that's legs. So when we talk about legs, that's really what we mean by the two congruent sides. So if instead all three sides were equal in a triangle, then we would say they would all be legs. Now, the third side of the triangle, if we have just exactly two sides equal, we call the third side the base. Now we use base a lot, and sometimes base is associated with a side of a triangle that's like maybe sitting horizontal, but that really has nothing to do with the word base at all. In this case, base just means the side that's across from what's called the vertex angle. So the vertex angle, you know how the points are called vertices, right? But then this particular one, the vertex angle, is the angle that's formed by the legs. In other words, the two sides that in the triangle that are congruent. So you can see these definitions are all over here. We see the congruent sides are called legs. The angles formed by the legs is called the vertex. The side opposite the vertex angle is called the base. So again, that vertex angle right here is the angle that is formed by the two legs, or the equal sides. And the angles that have the base as a side, so that would be these right here, they have one of the sides that help make them is the base. They're called base angles. And that's really important when we learn theorems like the isosceles triangle theorem, because it uses this terminology. And that theorem says this: if two sides of a triangle are congruent, in other words, if you have an isosceles triangle, then the two angles opposite the sides are congruent. So the two sides opposite them are congruent. So what they're saying then is, in this triangle, if these are the equal sides, then these would have to be equal angles, because they are the angles that are across from the equal sides. And if you think about how triangles are formed, when you think about the bigger that you would make an angle between two sides, then, so like for instance, these two sides right here, right? So the bigger that I make that angle, so if I open up those sides a little bit more, the angle would be bigger. It'd make the side across from it larger. But if the angles were the same, then of course the sides across from them would have to be the same. So logically, you can see how this theorem makes complete sense. So again, just to recap a couple important things, base angles in isosceles triangles are always equal. And then the base is actually called the side that's across from the vertex angle. And the vertex angle is formed by the two equal sides. Now these are all kind of typical of the triangles with two equal sides, but of course this whole logic also works when you have three equal sides. And that's actually the next kind of triangle we're going to look at, which is called the equilateral triangle. So if, no matter how you look at the triangle, any two given sides are equal, in other words, all the sides are equal, then we call that instead equal lateral. And if a triangle is equilateral, in other words, equal sides, lat means sides, then it must also be equal angular. And the reason why that is, in other words, the angles must be equal. And the reason why that is because of that base angle theorem. It's like no matter how you look at it, if say you look at these two sides being the equal sides, well then the angles across from them have to be congruent, right? And then instead, if these are the two equal sides, then the angles across from them must be congruent. And then you could use that logic all the way around the triangle, and that would prove that if all three sides are equal, then all three angles have to be equal as well. And that's what these theorems say. So if a triangle is equilateral, then it must be equal angular. And then also the converse of that is if a triangle is equal angular, then it's equilateral. So let's say you don't necessarily know the sides are equal, but you're told that all the angles are equal. Well, then you can also conclude that the sides must be equal as well. So with a triangle, you can't be one without the other. Well, think about, in the future we're going to study quadrilaterals. That is not the case in quadrilaterals, okay? If you think about, you could have a figure with all equal sides that's four-sided, but all the angles don't have to be equal. And that's called a rhombus, right? You could also have a situation where you have all angles being the same, but not all the sides would be equal. That's a rectangle, because remember, a rectangle has all right angles, so all the angles are equal, but the sides aren't. Now, there is a quadrilateral that has both, and that's the square, right? So the square would be considered the equilateral quadrilateral. That's a lot of laterals, right? But so we just give it a special name called the square. So this idea of equal angles and equal sides being across from them is true in triangles, and that's the extent of how we can reason that. Is we have to kind of say, okay, if it's a three-sided figure, if it's a triangle, then we know that these facts are true. So although we can use these definitions in lots of different scenarios, we basically in this lesson are just going to use these theorems to find missing parts in equilateral and isosceles triangles. So our first goal will be to look at the figure, see if it's isosceles, or if it maybe is even more specialized than is equilateral, and then apply these theorems. So looking at example A, it says find the indicated measure. So they want me to find this angle right here. And I can see in the from the markings that this has these two equal sides. And what that means is that that these angles across from them, so that angle and this angle being the angles across from those sides, have to be the same. And that means that x must equal 65 degrees. In B, we got same scenario, except for this time, so we've got with the two equal sides, right? But this time they want us to find this angle. So this will take a little more kind of connecting the dots here. So if we have these two sides that are equal, then we know the angles across from them are equal, right? So we know this angle is 70. That means this one over here has to be 70. Well, the missing angle, x, has to be the rest of 180 degrees, right? So that x would have to be 180 degrees minus what these two angles add up to, which is 140. And that means that x must be 40 degrees. So we used that base angle theorem that isosceles triangle theorem, in other words, that says that if two sides are equal, then the two angles across from them are equal in a triangle. And we had to use it indirectly. We used it to find the measure of the angle that was 70, but then using that and combining it with the triangle sum theorem, we could find the actual requested angle, which was 40 degrees. Okay, so in C, this time we've got 3 sides marked equal, all 3 sides. So no matter how we look at this triangle, no matter which 2 sides we focus on, we've got an isosceles triangle. And that means that any 2 angles that are across from these 2 equal sides must be the same measure. And that actually means that if this angle is 60, this one has to be 60, but then this one has to be 60 degrees. And that actually is the case for all equilateral triangles, that all equilateral triangles have 3 60-degree angles. If we wanted to kind of add an add-on for this equilateral triangle theorem, we could say, so in other words, all angles equal 60 degrees. So that's a fixed measure in an equilateral triangle. That's the only way it will work, that they're all equal, is that each one of them is a third of 180, which is 60 degrees. Okay, so let's designate D a U-tri question. So just D, because then we're going to move on and look at finding sides in the next 2 examples. So take a quick second to pause the video and find the measure of the angle labeled X. Pause the video now. Okay, so this one was similar to B, where this time they were asking for the vertex angle. So remember, the vertex angle means the angle where the 2 equal sides meet. And you can see that we've got the 2 equal sides here, right? So that's the vertex angle they're looking for. So we know that the angles across from the equal sides have to be the same. So that one angle here I have labeled as 53 would be the other of the base angles. And so those angles together make 106 degrees, leaving 74 degrees for the angle labeled as X. Okay, so E and F. So taking a look at E, I see that they want me to find the length of a side. Well, now the thing that's really nice about finding angles is there's a set sum in triangles. All angles add up to 180 degrees. That's not the case for sides, right? So we don't have anything like that to use with sides. But I can tell from looking at these markings that I've got 3 equal angles, which means this is an equiangular triangle, which means it's also equilateral. And that means all those sides have to be equal. So that's a conclusion I can make using that theorem that says if a triangle is equiangular, then it's equilateral, which is that theorem right there, the converse of the equilateral triangle theorem, right? And that means that the missing side must be 10 units long. It might be feet, inches, we don't know, but it's 10 of whatever the same units are of the side that's given. Now in F, we have just 2 angles marked equal, but those angles are across from these 2 sides, and we know that if the 2 angles are equal, the 2 sides across from them have to be the same, and that means this side labeled as X must be 7. Okay, so now we get the hang of that, and now we're going to kind of move on and go to the next example and involve some algebra. So example 2 asks us to find the value of X. So we have an expression here that is describing angle 2. So that's this angle right there. And it says that that angle is 2 plus 8x. So let's see what else we can find in the triangle. Well, we've got these 2 sides marked equal, which means that the angles across from them must be the same measure. And since the one angle is 45, then this one over here must also be 45. So because we know that the 3 angles have to add up to 180 degrees, and we've got 2 45-degree angles that then add up to 90 degrees, right? So we're going to take both those 45-degree angles away, leaving us with 90 degrees. That way we know that angle 2 must be 90, and because that expression 2 plus 8x is describing that angle, we could use this equation then to find out what x is. 2 plus 8x equals 90. So all we have to do to find out what x is then is just follow our rules for solving, which is reverse order of operations. So we subtract 2, and we end up with 8x equals 88, and divide by 8. That means x must be 11. And that's what they ask us to find x. So there's our answer. Moving on to look at B. So again, they're trying to find the value of x, and they tell you that the measure of angle 2, which is right here, is 8x minus 6. So let's look at the other clues we have in the triangle. So we see this angle here that's 66. We see that these are the marked sides that are equal, and we know that means the angles across from them have to be the same, meaning that angle 2 must be 66 degrees, and that means this expression must equal 66. Again, just once we've got the equation, it's just a matter of using the algebra. So I'm going to add 6 to both sides, leaving me with 8x is equal to 66 plus 6 is 72. And then, of course, our last step is to divide by 8. And we've got our final answer for x, which is 9. So x must be 9 for this triangle to be accurate, because then when we substituted that back in, we would get an angle that's 66 in that position where angle 2 is. So this is a good time for some you-try questions. So we're going to go ahead and designate C and D to be you-try questions. Okay. And in each one, you're going to find the value of x. So when you're done, you're going to be able to say x equals blank, whatever that might be, using the facts that you see labeled on the triangles. So go ahead and pause the video, give C and D a try. When you're done, you can tune back in. We'll talk about what the correct answer should be, and then we'll wrap up our lesson looking at some applications with the side links that involve algebra as well. So please pause the video now. All right, so thanks for giving those two a try. So looking at C, we can tell that that missing angle must be 60 degrees because all three sides are marked equal. And that means that the value of x must be 7. So writing the equation -3 plus 9x equals 60. And solving it will give us a value of 7. Same situation for D. That turns out to be an equilateral triangle, so every angle must be 60. And that means the value of the angle, which is 60 degrees, must equal 10x, leaving x to be 6. Okay, our final question. So this time in E, we've got angles marked equal. So instead of sides, we've got the angles marked equal, which means that, of course, all the angles are 60 degrees, but that's not helping us here because the thing that they're asking us to find has to do with sides. But we do know this, that if all of the sides or angles are equal, then all the sides would have to be equal. And that means that this part right here labeled with 2x minus 11 must equal the same thing as this over here, this side, which is 9. So that gives us an equation we can solve. So first step, add 11 to both sides, and that leaves us with 2x equals 20, and then x must be 10. Because I divide by 2, I get 10. So x must be 10 to make those sides all be 9. And again, in F, we've got two angles marked equal, which means the sides across from them must be equal. And that means that this side that's labeled as 2x minus 15 must equal 7 because the two sides have to be the same length. And then just a matter of solving the equation. So I'm going to undo any adding or subtracting by adding 15. That's going to give me 2x on the left-hand side, and on the right side I've got 22. 7 plus 15 is 22. Divide by 2, and I've got my final answer. X is 11. So although you'll see that we will do so much more with equilateral and isosceles triangles, and knowing more about them tells us about other figures that contain isosceles triangles or equilateral triangles, or maybe if we take an equilateral triangle and we split it in half, that's actually going to lead us to talk about some special things down the road when we study trigonometry. But these just kind of are the basic information about these two types of triangles, and they are very special triangles that you will absolutely see again. But that does it for today's lesson, so I'll see you in class.